So let's indicate that it's going to open down. Secondly, you should notice that inside we have -2 and on the outside we have +3. That means our vertex we're going to find by switching the inside and keeping the sign of the outside. So our vertex will be +2, +3. So in this blank here for vertex, I'm going to put 2, 3. Now that's very helpful to graph because that means from the origin, we're going to go to the right 2 and up 3 and put a point. If y'all remember that your rate of change is opposite on either side, you would know that the slope of the right side is going to be -1. So we can, from our vertex point, go down 1 over 1, down 1 over 1, down 1 over 1, continually. And likewise on the other side, we can have a slope of +1 because slopes of either side of the absolute value are opposites. So I'm just going to go down here. So this is how you would graph it without a calculator or table, or just using the using what you know about the vertex and the rate of change. You can fill in values on your table. You could graph this by going to y equals and typing this in. Remember, to get to absolute value, you go to math, then arrow right to number, and then choose number 1, ABS, for absolute value, and then type it in just like you see it. When you look at the table, some order pairs you might want to use to graph are on this table, so I'll just include those. So the point 0, 1 we see on our graph, 1, 2, 2, 3, 3, 2, 4, 1. So make sure you put a list there. And also your domain for this function. Remember, the domain for all absolute value functions is all real, so we list -infinity to +infinity. Keep in mind that domain are all your possible x values, so your lowest x and highest x. As this graph extends to the left forever, we approach -infinity, and as it approaches the right forever, it approaches +infinity. However, your range, just like we defined earlier, is your lowest y to your highest y. So for this graph, if we kind of move our pencil from the bottom up to the top, you notice that it's coming from -infinity, so that's our lowest y, -infinity, but our highest y stops here at 3. So our range is going to be from -infinity to 3. And at the number for our domain or range, we include that point by indicating a bracket. The only time it would ever not be a bracket is if it had an open circle. So make sure you have a bracket on the number, and always list your numbers lowest to highest. So our domain's lowest x to the highest x, and range lowest y to the highest y. So that takes care of 4. For numbers 5 through 7, you are asked to solve each equation, check your work, and follow the appropriate steps and show your work. So I am going to do this on a separate sheet of paper. So I have the problems already written here. So first I'm going to do problem 5. So it's very important that we remember all of our steps for solving absolute value equations, the first of which is to isolate the absolute value. In this case, for number 1, our absolute value does not have any addition, subtraction, multiplication, or division outside of the absolute value, so we can skip step 1 and move on to step 2, which is to write our 2 equations. So remember, we don't know if the value of A is coming from the left or the right on a number line of 0. We just know that our distance from 0 is 29. So we have to account for that by writing 2 equations. 1 minus 5A equals 29, and 1 minus 5A equals -29. So we just solve these individually. Please don't get caught up in this minus sign thinking you're supposed to add 1. The 1 is positive, so you do have to subtract it from both sides first. This zeroes out, so -5A is equal to 28. And then when we divide both sides by -5, we get -28 fifths. So that's one of our answers. For the second one, likewise, subtract 1. The difference over here is we're going to get -30. Divide both sides by -5, and A is equal to +6. don't forget you can check your answer by storing negative 28 over 5 as x. So in your calculator, on your home screen, you would type in negative 28 divided by 5, hit the store button, which is located above the on key, choose x and hit enter. Then you just type in the absolute value of 1 minus 5x in your calculator, and it should come out to equal 29. So I'll put a question mark. Does it equal 29? If so, that means it's the correct answer. And then you can repeat that process for 6 as well. For problem 6, again, let me go ahead and finish these steps. Solve. N4, check. Check your answers. All right, so for number 6, our absolute value is not isolated. We actually have a minus 5. So to solve here, we need to add 5 to both sides. When we do that, we get the absolute value of v plus 8 is equal to 7. Now it looks like number 5 does, where our next step is to write our two equations. So we have v plus 8 equals 7, and v plus 8 equals negative 7. When we subtract 8 from both sides, we get negative 1. And over here, we get negative 15. So checking both of our answers, they both will check out. You can follow the same process I described here in terms of storing your value for x and typing in this right here, the absolute value of the quantity v plus 8, subtract 5. And if it equals 2, then your answer is correct. For number 7, we've got 2 steps to isolate our variable here. Always remember that when solving, you undo addition or subtraction first. So we're going to add 9 to both sides. Oh, shut up. Did it stop? Sorry about that. I thought it stopped recording. We're going to add 9 to both sides first. And then 57 plus 9 is 66. Our next step is to undo addition multiplication or division. And since this is 6 times the absolute value, the inverse would be to divide both sides by 6. By doing so, we get the absolute value of 1 minus 5x is equal to 11. Now our problem looks like number 1 and this step here at problem for 5 rather, and 6. So at this point we want to write two equations. 1 minus 5x equals 11 and 1 minus 5x equals negative 11. Please remember that this is add 1. If we were to read this, this would be 1 subtract 5 times x. So to make this 1 go away, we do have to subtract the 1 first. We always undo addition or subtraction first. So be careful there. Bring down your minus 5x. Don't lose that minus sign. 11 minus 1 is 10. If we divide both sides by negative 5, we're going to get that x equals negative 2. And positive 12 fifths. Okay. I apologize. I just recognized now that when I did your key and sent that to you, that I actually had 16 fifths instead of 12 fifths. So that should be 12 fifths. I made a math error there. All right. Next, we're moving on to inequalities. And these are pretty much the same steps with the addition of having to recognize if it's and or. And you also must draw an inequality to represent your answer, as well as indicate your solution in interval notation. So to get started, step 1 is to isolate your absolute value, and for number 9, it's already isolated. So that means I can move on to step 2, which is to write my two inequalities. But that means for my first one, I drop my absolute value, and then I decide if I have an and or. This is important because I have to graph my solution. If it is less than when my absolute value is isolated, remember I taught you to remember less than. It points to the left. Left is less. So this is less than. That's important because I need to use the word and in between my two inequalities. In my second inequality, I write down 6 plus 9x, but then I change my less than or equal to greater than or equal to, and I still change the sign of my 24 to negative 24. Oops, I forgot my negative. To negative 24. Okay, very important step. Then I just solve both of these like normal. So subtract 6 first. Divide by 9, and I'm going to get x is less than or equal to 2. And notice I'm bringing that word and down. 9x is greater than or equal to negative 30. Oh, I didn't reduce it either. If I divide both sides by 9, I can reduce this, so this should be x is greater than. Both of these are divisible by 3. You can put it in your calculator and hit math enter, but you'll get negative 10 over 3. So this is important because you've got 3 things to write after this, but this is not your whole answer. You need to, on a number line, put the smaller number on the left. This would be, in this case, negative 10 thirds. We would have a closed circle as indicated by the equal to sign. This larger number, the 2, goes on the right with an equal sign under it, so we close the circle. And means you shade in between. This means that any number in between negative 3 and 1/3, which is what this is negative 3 and 1/3. Any number we pick between negative 3 and 2, if we were to plug into this inequality, would make it true. Now, to write this correctly in set notation to get full points, you need to just take your variable x, put it in between the 2 numbers, and use less than or equal to signs. Your signs here will always point left for a compound inequality. The last thing you should do is write this in interval notation. So you just put the smaller number on the left, the larger number on the right, and if it has equal to, you'll use brackets around them. So these are the 3 things. When I say this is a 3-point problem, these are the 3 answers I'm looking for. The correct number line, the correct compound inequality, and interval notation. So this is your set notation, and this is interval. Okay? And lastly, number 10. For number 10, I'm going to do similar to how I did over here for 9 in that, well, actually, I forgot 8. I'm so sorry I skipped 8. I'll go back to that after I do 10. We need to isolate that absolute value. In this case, I'm going to add 9 first. When I do that, I've got 7 times the absolute value. Notice I'm bringing every step down each time. It's going to be 21. Then I divide both sides by 7 and get m over 3 is less than 3. So, I'm sorry, absolute value of m over 3 is less than 3. Now, my second step, again, is to decide if it's and or and write my 2 inequalities. So I'm going to have m over 3 is less than 3. And because it's less than, m over 3 is greater than negative 3. Now, when I solve this equation, put my pen here. When I solve this inequality, the inverse of dividing by 3 is to multiply both sides by 3. So that's going to cancel out, and I'm going to have m is less than 3 times 3, which is 9, and m is greater than negative 9. Okay, so I'm going to go ahead next and write my number line with my smaller number on the left, my larger number on the right, open circles, and always means I shade in between, put my variable in the middle, and use my less than signs. Because I do not have equal to underneath this, when I write this in interval notation, I will use parentheses. So we use brackets if it has equal to, and parentheses if it does not have equal to, because it is excluding the values of negative 9 and 9 as solutions. Alright, so I apologize for skipping 8. Let me go back and take care of this one. This first inequality to solve, and we still, again, isolate that absolute value, so we would add 3 to both sides. And we get x minus, the absolute value of the quantity x minus 4 is greater than 8. So again, step 2, write my two inequalities. X minus 4 is greater than 8, or x minus 4 is less than negative 8. So please remember, I taught you greater. So that or is important because that usually means that we shade opposite on the number line. Occasionally it will overlap, but that it will only overlap if this number here ends up being negative. So don't worry about that. Just go ahead and add 4 to both sides to solve, and we get x is greater than 12, or x is less than negative 4. So on my number line, I'm going to put my smaller number on the left, that's negative 4, my larger number on the right, that's 12. Because I don't have equal to, I'll have open circles, and I will shade greater than 12, so it points to the right, so shade to the right. And here, it points to the left, so I need to shade to the left. Now, this one here, this is set notation. There's no way to combine this as a compound inequality like we did for 9 and 10. The last thing we need to do, however, is write this in set notation. So you need to remember that if you go left forever, you're approaching a value of negative infinity, and if you go right forever, you're approaching a value of positive infinity. So your interval would be negative infinity to negative 4. I'm going to use a parenthesis again because it does not have equal to, union 12 to infinity. So these are the three things I need to see for your solution. All right, I hope that helps you with the absolute value part. The last video will be on piecewise.